This talk is on how to build a LayerCake framework. A LayerCake framework is built from one or more framework layers. Each layer has a layer definition file. It may mark certain framework classes with LayerCake annotations and can use annotation layers to avoid creating new types without writing new code. You can add code templates that customize how the new component, object operator, scopes, and getSetProperty operations are implemented in compiled mode. You can add wrapper classes to inject data binding, add missing properties, etc. And you can use plugin classes to customize LayerCake at a low level. The layer definition file is the primary configuration point for adding a layer. It essentially replaces the build.xml file that is included in each layer with a file that's specified per framework layer. Imports in the layer definition file are passed on to application code, giving you a nice sandbox of types that you can use. Any precompiled Java code can be added as libraries to the class path. The start method of the layer definition file is implemented in Java, which makes it easy to validate, install, and update third-party libraries. And you can use the layer definition file to configure the build system to conform to a specific project system's requirements, like where to put the source files, where to put the generated class files, etc. Here's the sample layer definition file for the Swing core layer. The key point for a framework developer is the start method. Here in this start method, two new file types are added for PNG and GIF. The files will get copied into the builder, the right location, unless they're being overridden by a subsequent layer. The main init annotation is defined here as well. It adds any class that's marked with main init into a type group called main init. That's then available to the code templates for the LC Swing main. Those code templates simply access those objects after the application is started. The compiler settings annotation is one of the primary configuration points for setting LayerCake features. You use it to set object, new component, and scope templates. Use it to turn off use of runtime reflection for that type or any subtypes. Instead, code that gets and sets properties or invokes methods is generated so that data binding can access those properties at runtime. You can also mark a constructor as being propagated automatically. So if a new type does not define that constructor, the superclass's constructor is invoked automatically instead. This makes it easier to do declarative applications even when there's no zero argument constructor. You can package up both source and class files into jars automatically. And if necessary, you can disable the use of dynamic mode for a given class or any subclasses. And you register the child manager and object manager to manage children for dynamic objects. Some other annotations you can use, the @component annotation. You can mark properties with @bindable to either enable data binding or inject data binding for a given property. You can mark properties as constant. This disables the ability to set that property and disables warnings that would otherwise be generated by data binding expressions on those properties. And you can mark entry points to your application using @main_settings. The main settings has various properties for controlling packaging of the resulting application, like the name of the script that gets generated, whether files get put into a jar file, and what that jar file's name is. And framework layers can use their own annotations, like the @main_init annotation in the Swing layer, or the GWT module annotation, which you can put on an entry point like an activity and have the configuration for that entry point be generated automatically. Annotation layers let you mark pre-compiled Java classes with these annotations. You don't have to generate a wrapper class, so you can just use the existing class name, and when LayerCake uses that class, it applies the annotations. This example shows the annotation layer for the swing package. It simply has to mark itself as being an annotation layer, and then it can't include any code. All it can do is include annotations. So it can mark the point class, X and Y properties as being constant, and here it can associate code templates with the J menu, one of the few swing classes where we didn't need a wrapper class to add data binding. It also sets the Dyn child manager so that we can add and remove menu items from the menu at runtime. The Android view type is another interesting case where you can see the power of an annotation layer. Any view type in Android or any subtype of the view will use this view obj template and the view new template when a new component is created. It will also cause the constructor for any view or any subtype of view that takes the context parameter to be propagated to the child automatically unless it's overridden. The combination of these two features lets us use any view type in an object tag in LayerCake. Here's the view obj code template. It looks a little bit like JSP, and then it can include parameters and mixes Java code and definitions that are output as part of the class definition. It uses a highly structured set of variable names, so the code is fairly small, but key points can be customized, like here where we inject the name of the root object in the class hierarchy, which will be in Android's case an activity or a service, and that will provide the context parameter that's required. So even though we don't have a way to pass constructor parameters to objects, they can be injected by the framework behind the scenes. It also enforces the constraint that a view object be included inside of an activity, which is a constraint that Android has as well. There are many cases where to fully exploit LayerCake you need a wrapper class, like to inject data binding behavior. And this may be as simple as adding @override @bindable prop name for each property that needs data binding. Or you can add event listeners and inject a send event call. You can add additional styling interfaces to take advantage of LayerCake's multiple inheritance, and you might need init start or stop hooks for a given type to do some initialization or teardown. And you might add some properties that just aren't there. They might be exposed as events only, so you need to add a property. Here's an example wrapper class for the swing JLabel type. In this case, it uses the same name JLabel, so that if we need to add a new wrapper class, we don't actually have to change the client code. It implements a styling interface, and here it marks a manual property for data binding. This means that we're already sending all the data binding events needed, but we don't generate a warning for the text property if it's used in a data binding expression. When the text property changes in swing, we both adjust the size of the label, which affects the preferred size property, and the text property itself changes. The icon property is implemented and has similar effects. It's marked though as @bindable without the manual equals true. That means that LayerCake will inject data binding for the icon property itself, but we still have to mark the preferred size property as changed. These two actually do the same thing, but it shows the difference between @bindable with manual equals true and without. Since preferred size, we're already sending the events, we can mark it with manual equals true, but we do want to inject data binding automatically for size, location, visible, foreground, and background. Plugin classes are used to customize LayerCake at a lower level. For example, the binding manager class can be implemented to control queuing and threading for invoking data binding events. The child manager and object manager are used for dynamic object support. And file processors are used to add new file types and control how files are copied, generated, and merged. Scope and annotation processors let you do either simple basic customization like we saw with the at-main init annotation, or you can do arbitrary transforms of the program model. Scopes let you mix in code templates to add additional code to the parent class that might be necessary to implement the scope. Let's go through the basic build and run process for LayerCake. First, all the layers are started in the order in which they're specified. They can add classes to class path, add file types, set options, etc. If necessary, the pre-build phase is run for any processors that need to generate Java code that's required from the later phases. The process phase then can transform any LayerCake code to Java code. If enabled, the compile phase will run the Java compiler on changed files. Then any post-build commands are run. And if any main methods have been registered, those are invoked. Actual framework layers in LayerCake don't take that much code. Here's kind of an overview. And the swing is the most complex, the most complete, and it's 3,000 lines of code, largely because there were no easy way to centrally add data binding events, and lots of wrapper classes were needed. Android was the cleanest framework and only took 600 lines of code for exposing most of the Android APIs cleanly in LayerCake. Wicket was fairly complicated due to state management, serialization, threading problems, but it still is still less than 2,000 lines of code. And GWT, for all of the complexity involved in converting Java to JavaScript and its separate runtime, was only 1.6 thousand lines of code for about 50% complete. And the other frameworks took hardly any code because it's just a few annotations and very simple layer definition files. So in summary, building LayerCake frameworks is not that hard. It's a very elegantly designed system, and I think it has three major benefits. One is that you can easily get a hybrid dynamic and compiled system for existing Java frameworks that works in a much more declarative manner. You can eliminate the create project step with layers, and you get the benefits of an integrated build-run system, so your applications are easy to start and easy to change. So that's it for the Building Frameworks talk. There's one more talk on the LayerCake architecture if you'd like to learn more, and thanks for watching.